Hello everyone, my name is Funky. I'm the cabling system specialist and lab director. Today I want to talk a lot about the Power Ethernet concept and something about how we assess our product in our lab. So Power Ethernet is a new technique. Basically, it means you use just one single cable to transfer the data and deliver the power in the same time. So for some of the small electronic devices like camera, like IP phones, like the monitors or laptops, you can power them up by just using one data cable. So you can save up the power cable, which means you can reduce your system budget. Now for the POE standard, the first standard is the IEEE 2.3AF. In this standard, they define the POE system up to 15 volts power with 350 milliamp current. The next standard is IEEE 2.3AT. In this standard, the maximum power raised up to 30 volts and the maximum current is 600 milliamp. The latest standard for POE is IEEE 2.3BT. In this standard, you can use up to 4 pairs in a single cable rather than just 2 pairs. So the maximum power has been doubled up to 60 volts with the 600 milliamp current. And if you can deliver 1 amp current, then you can transfer maximum power up to 90 volts. The traditional data cable uses 4 pairs. However, for nowadays in the automation and automotive industries, you can use just single pair twisted pair cable. So for this kind of cable, you can still use POE technique, which is called power over data line. The technology is the same. You just use one single cable to transfer the data and deliver the power in the same time. For the PODL standard, the first standard is IEEE 2.3BU. This standard defined for the 100 base T1 and 1000 base T1 physical layers. So you can receive the maximum power of 50 volts with a 1.36 amp current. Now for the latest SPE standard, IEEE 2.3CG, it defined PODL for 10 base T1L. So you can receive up to 52 volts power with nearly 1.6 amp current. Now let's talk about how the POE will impact your cabling system. When the DC current flows into the conduct, then the conduct resistance will dissipate some of the energy into heat. So you can calculate this energy by the Ohm's law. Imagine in a real-life installation environment, people tend to bundle the cables together. So you can see the central element of the cable will be the hottest point in the whole bundle. Then one important thing is you have to assess the central element to make sure it's working under the 60 degrees, which is the normal highest operating temperature of the data cable. The next thing is, when the temperature raised, the resistance of the copper will be increased as well. Then that will affect the insertion loss of the cable. So another important thing is you have to assess the insertion loss of your Lincoln channel to make sure they will not exceed the maximum requirement. So in our German lab, we will apply those international standards to assess our product's temperature rise when the POE is on. The test method is defined in the IEC 61156-1-4. We can have a look how we actually test it in the lab. So we have a stand and we wrap up the cables here. Then by a certain number of the cable elements, we bundle them up and fit into the thermocouples in the central element. Then we use this power supply to inject into the DC current, then use the thermocoupler to monitor the temperature. So we can monitor the ambient temperature here and monitor the temperature inside of the cable bundle, then we can calculate the temperature rise when the DC current is in. We can roughly see the numbers, and this is coming from a kind of category 6A UFTP cable. For those different ambient temperatures from 20 degree to 50 degree, and by the different number of the cables from 24 to 172. You can see those green numbers means the central element is working under the 60 degree, which is safe. While for these red numbers means the central element actually exceed 60 degree, which is not recommended. Besides the cables, we also assess the connectors. For the connectors, the technology is the same. So you have to assess the connectors can carry the same amount of the current by the same amount of the temperature, same as the POE test in the cable. This kind of test is called current temperature derating. So by giving a certain ambient temperatures, then you have to test how your connector can carry a certain amount of the current, then your curve shall exceed the requirement to make sure your connector can carry. Another thing for the connector is people intend to unplug the patch cord from your outlet when the POE is up. So when the plug is touching the jack or leaving the jack, the touching point will have an arc discharge here. This arc discharge will damage your copper surface. Then an important design for the connector is you have to make sure your arc discharge point is different to your final meeting point. You have to have a safe wiping zone to make sure the damage will not affect your connection. So in our lab, we will do this kind of test. We will give the connectors a certain number of arc discharge, and then to make sure this damage will not affect the connection, then we will test the contact resistance of the connector to make sure they are still available. So these are all the POE content for today. Just to sum up, the POE is very important and very popular now. So it will be applied to the CCTV, the smart building, the automation and automotive areas. In the Jolon lab, we will assess all our products, including the cables and the connectors, to make sure they can support the POE or the environment. So if you have any questions, please leave your message in the discussion area. Thank you very much.